I made a 3D graphing calculator in Minecraft on a 3D graphing calculator. You plug in a function and it generates it. I was told that it was impossible, but after over 100 hours of effort and many long nights, it's finally complete. This is the story of how this project came to be. Hey you.
What?
Good.
This is a redstone machine printing a sphere. A few hours ago, I typed in this equation, and now it's literally printing what that looks like. But that's not all. This machine can print nearly any equation you type in. From curved sheets to this saddle-looking thing to whatever this is, it'll print it using no command blocks and no mods. I've been dreaming of this project for over 5 years, and I'm happy to say that it's finally real. A 3D graphing calculator with just redstone.
My friend Joe suggested I make a 3D graphing calculator in Minecraft on a calculator, but I brushed him off in class. I told him a 3D graphing calculator inside Minecraft, inside a calculator, was probably just impossible. I live in Southern California, and driving around the hills and the water, I like to think about how programming relates to it. I have made a voxel engine before, but it was designed using modern shaders and runs on a modern computer. I designed the engine using a custom WGPU abstraction. This project is great, and I'm still very invested in optimizing and improving on it. But really, this is the kind of thing that anyone interested in graphics makes eventually. Somehow, the appeal of having Minecraft in your pocket on a device designed for basic calculating seems so elusive that I just couldn't help but wonder. I was trying to listen to music, but all I could think about was the architecture of my calculator. Could it handle voxels? How would the rendering or the memory allocation really work? And the more that I thought about why it couldn't be done, the more I started wondering if maybe it could be. It was a thought I really just couldn't shake. I realized that if I was going to get any sleep that night, I would need a definitive no. The next day I woke up bright and early and went back to college. I talked with Joe while walking to class. Yeah, I don't know if it's possible.
Anything's possible if you put your mind to it, man.
I realized he was right. Anything is possible, and anything worth doing is hard. So I decided to ask someone who knows a lot more than me, my computer science professor.
Meow, 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 meow. Meow. Meow.
He told me that it's impossible. First, he pointed out that the CPU on the TI Inspire runs at a mere 396 MHz. Second, it has 64 megabytes of RAM, less than some toasters. 64 megabytes is barely enough to hold a single high-resolution photo, let alone a graphing simulation. Finally, he noted the rendering. Calculators are designed to draw flat 2D lines in a graph, and the Inspire barely has the capability to calculate 3D spatial depth. Walking out of his office, I have to admit, I thought he was right. 396 MHz and 64 megabytes of RAM is not enough. It just couldn't be enough to render a 3D world, let alone a surface in it. So I went back home, threw the calculator on my desk, and decided to give up. I sat there staring at the calculator when I remembered something about my professor's argument which was flawed. He forgot about jailbreaking. You see, he assumed that I was going to run my code inside of their slow lockdown operating system. If I had done that, then truly it would be doomed. Basically, TI locks down the calculator for standardized testing. Without jailbreaking, you are restricted to writing and running programs in TI Basic or Lua. While Lua is fine for simple math scripts, both languages run too slowly to handle complex graphics, fast action, or games. Jailbreaking unlocks native code in C and C++, exploiting vulnerabilities in the TI Inspire operating system to bypass the digital signature checks. And by running native code, we might actually have a chance to make a game. But it was the weekend, so I decided I would take a little break. Then that Monday I spent the morning figuring out how to jailbreak my Inspire. It wasn't actually as difficult as I thought it would be. The next challenge was trying to figure out how to build the source code for myself. I actually didn't anticipate how much of a challenge it would be just building the file. Here's the week's worth of effort to just build for the Inspire. There are about 1 million different errors, warnings, compiler complaints, and just pure confusion which prevented me from building a file which I could run. And this is only page 1. But eventually, somehow, perhaps even by accident, I managed to build it. So that night I had an engine, I had a dream, and I had a test in the morning. The professor said we were not allowed calculators for any exams in this class. Bringing one would be cheating, and my peers wouldn't stoop so low. Almost every single person had a calculator. And of course, my professor didn't do anything to stop them. But it's fine, I'm good at tests, and have nothing to fear. Yeah, I got a 68%. But the class average was a 63%, so I can't feel so bad. And Joe got a 28%, so I did much better than him. But somehow it just really doesn't seem fair. It's like he thinks I can't succeed, and I want to prove him wrong. I'm tired. I'm burnt out. God, is it annoying programming for the TI Inspire. Every single time I would have to click compile, then I would have to wait for it to compile, and that took forever. And then I would have to go through TI's Playhouse of Horrors just to get it to send to my calculator. And then once it's on the calculator, you think, okay, that's fine. Error, nope. Because you have to re-jailbreak it, so I have to go back through the entire process of re-jailbreaking it, and then and only then will I be able to run my file. Every single time. So I mean, when I tell you that it was unpleasant, I do mean it. But it's done with. I've got a version of the game which, frankly, I'm very pleased with. You can see I can place blocks, craft, jump around, I even have mobs and collisions. Frankly, I'm very pleased with this point in the project. Part of me almost wants to end it here, and be satisfied with all the work I put in up to this point. But then I remembered something. I remember what Joe told me.
Anything's possible if you put your mind to it, man.
And he was right again. This is not all I had set out to do. I didn't spend a week breaking and unbreaking my calculator just to play some scuffed version of survival. I had to snap out of it. I had to keep my promise, and I had to get back to work. So, having built something resembling Minecraft, I began making the graphing calculator. But to do that, I figured I would have to have some basic understanding of redstone logic gates, so I found some tutorials on how to do that. But the more that I watched and tried to replicate, the more I realized I had no idea what I was doing. But eventually I got an XOR gate working in the game. And you can see that I can take in a single bit and add 2 bits together. But this is certainly not a graphing calculator, nor anything more than just a single circuit. So I was stumped. Doing more than a simple circuit on my desktop took a couple of hours, and trying to do it on the calculator seemed again impossible. So the next day when I went back to school, I decided to ask Joe. Any ideas?
Well... no.
He was just as stumped as I was, and although I wanted to keep working on this problem, we had another test, this time in physics. The previous test I took had made me very apprehensive about this exam, but this was physics, and being so I was a little more excited. She had a very different approach to testing than my math professor. First of all, there was no time limit, so I didn't have to worry about running out of time. And second of all, we were allowed any calculator we wanted. When I finished the exam, I actually felt confident that I did well. And I did. I got a 92%, and the class average was a B. And Joe got 100%. Afterwards, I went and spoke to her about my project, and she was supportive and reassuring. After the terror that was differential equations, this was all really a relief. As a matter of fact, I saw my math professor while I was leaving for the day. But anyway, test done with, I decided to spend the rest of the day thinking about how I was going to fix my graphing problem. And actually, it was when I was in my office that I figured it out. The way that Matt Batwings created his graphing calculator was by, instead of evaluating the graph at every point in 3D space, he evaluates it per column. What I realized is that this is basically exactly how Minecraft handles its terrain. So what I would do is program it like terrain, but instead of evaluating parallel noise, I would evaluate it for a function. Some may say that this is less impressive than making it with redstone, and maybe someone smarter than me will. But to do it in Minecraft on a calculator, this is the only solution I could imagine working. So I got to work programming it. Yeah, it just crashed and didn't even work at all. But this really is a common thing with programming. You have an idea, and you can see it in your mind perfectly, but the act of making it is really the difficulty. I remember this one time I spent an entire year trying to fix a single glitch with shadow mapping. If you've never tried programming graphics, shadow mapping sounds like it should be easy. You just calculate where the light hits, right? In my mind's eye, I had this beautiful cinematic soft lighting, but on the screen my shadows were jagged, flickering, and broken. I would move a little, and they would shudder and disappear. And you have to remember, this is all before we had AI. I couldn't just copy-paste my code into ChatGPT and say, "This is broken, please fix it." No, I had to do it the old way. I had to watch hours of 10-year-old videos on how to do shadow mapping and read through ancient GitHub repositories trying to find that fix. In a way, AI really has made this kind of research financially unrealistic for businesses. But it is a little bit like gambling. They might say maybe one more prompt will fix it, just one more prompt. And without the ability to fix these kinds of basic problems, when we outsource our uniquely human characteristic, creativity, to a fundamentally uncreative machine, we lose the ability to solve problems which demand novel innovation. I'm still going to get a degree in computer science, not because I think that it will make me wealthy, but because I think we need people who will learn to solve problems which computers cannot. But philosophy time over, let me continue with the graphing calculator. So I went through the painstaking process of debugging, and over the course of that week I managed to figure out that it was, as usual, just a memory error. So I built it, and there it was running, but there was a problem. It was running at 1 FPS. To get it to run smoothly would take another optimization: pre-sampling. So the issue was that whenever I would attempt to render a chunk, I would recalculate not just the points of the graph, but the values for different functions like sine and cosine. What this does is slow down the rendering quite a bit. So all in all, instead of recalculating graph points every time they are accessed, I store them in a persistent map for reuse. And again, it was time to program it. But anyway, here it is. I can graph regular functions and implicit functions. I can also graph complex functions. It really did take a lot of work to get working, but now that it's done, I feel like I can finally rest easy. But that's all for this video. Thanks for watching.